If you recall from the first video, we had a graph that looks something like this. So in this video, we're talking about whether a relation is a function. And what we did in that video, at the very end of it, we looked at the vertical line test. And as we ran a vertical line across the graph, we said as long as it doesn't touch 2 points at the same time on the vertical line, that the relation is a function. And we got over to this side of it and said, well, that vertical line right there matches up with my vertical line test, so my marker, and that means that it's not a function. What you need to understand about this then is this is a single x value right here that's going to correspond with multiple y values. And so as you look at different situations outside of being a graph and you can't do the vertical line test, what you're looking for is a single x value that corresponds with more than one y value. That means that the relation is not a function. So if we can then identify, like in example A, that we have a single x value that corresponds to only one y value, then it is a function. So this first example, yes, this is a function. This is a function. All right, so the -3 going to the -2, the 0 going to the 7, and the 4 going to the 1. What would cause an issue is if I had one of these arrows coming out of one of these x values to an additional y value. So that's what you're looking for to identify if a relation is not a function. In example B over here on the left, we have a set of ordered pair given to us. And all I'm going to do is take a look through and see if I have an x value that repeats. And you'll notice here, I've got a 4 that repeats. And so why I'm looking at that is I've got a 4 that is associated with a -1, and then again over here, a 4 that's associated with a +1. So if you can imagine that this was 4, 1, 2, 3, and 4, we would have a +1, maybe it's right there, and we would have a -1, which is right there, and that would fail our vertical line test. So in example B, no, it is not a function.